Aluminum busbar trunking systems offer several advantages over copper, primarily concerning cost and weight. Aluminum is significantly cheaper than copper, making aluminum busbar systems more cost-effective for many installations. Aluminum is approximately 3 times lighter than copper, which simplifies installation and handling, particularly in large or complex projects. While copper has a higher overall conductivity, aluminum boasts a higher conductivity relative to its weight. This means an aluminum busbar can achieve a similar current carrying capacity as a copper busbar but with a smaller cross-sectional area. Aluminum is non-magnetic, which is beneficial in applications where magnetic interference could be a concern. Aluminum naturally forms a protective oxide layer that provides excellent corrosion resistance, especially in indoor environments. However, copper busbar trunking systems also offer distinct advantages. Copper possesses higher electrical conductivity than aluminum. This allows a copper busbar to carry more current for a given cross-sectional area. Copper exhibits lower electrical resistivity compared to aluminum, resulting in reduced voltage drops and energy losses along the busbar run. Copper is more flexible than aluminum, making it easier to bend and shape during installation, particularly when navigating tight spaces or complex layouts. Copper has a higher tensile strength than aluminum, providing greater mechanical stability and resistance to physical stress. Copper's high thermal conductivity enables it to dissipate heat more efficiently than aluminum, which is crucial in high current applications where heat generation is a major factor. There are also environmental and market considerations. Aluminum production generally has a lower environmental impact compared to copper production. Copper is typically more widely available than aluminum, although this can vary by region. Copper prices tend to fluctuate more significantly than aluminum prices, which can impact the overall cost-effectiveness of copper systems. The selection between aluminum and copper busbar trunking systems depends heavily on the specific requirements of each project. Factors such as required current carrying capacity, space constraints, and environmental conditions should all be taken into account. For high current applications where space is limited and heat dissipation is critical, copper might be the better choice. However, if cost and weight are primary concerns, and the application doesn't demand extremely high current densities, aluminum could be the more suitable option. When evaluating the current carrying capacity, always consult the manufacturer's specifications and relevant electrical codes, such as the National Electrical Code, or NEC, to ensure compliance and safety. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating, which can be used to determine the appropriate size of the busbar for the intended load. Voltage drop is another critical factor. The lower resistivity of copper results in less voltage drop over a given distance compared to aluminum. Excessive voltage drop can lead to equipment malfunction and reduced efficiency. The NEC recommends limiting voltage drop to no more than 5% in the branch circuit or feeder. The formula for calculating voltage drop is voltage drop equals 2 times the length of the conductor in feet times the current in amps times the resistance per foot of the conductor, all divided by 1000. When comparing aluminum and copper busbars, it's essential to use the appropriate resistance values for each material. Aluminum has a higher coefficient of thermal expansion than copper, meaning it expands and contracts more with temperature changes. This can be a concern in outdoor installations or environments with significant temperature variation. Proper expansion joints and hardware should be used to accommodate these movements and prevent stress on the busbar system. Corrosion resistance is another important consideration. While both aluminum and copper offer good corrosion resistance, aluminum is particularly well suited for environments where exposure to certain chemicals or pollutants is a concern. The protective oxide layer that forms on aluminum helps to prevent corrosion. However, in highly corrosive environments, additional protective coatings or materials might be necessary for both aluminum and copper busbars. The installation practices for aluminum and copper busbars are also different. Aluminum is more susceptible to damage during installation, so care must be taken to avoid scratching or nicking the surface. Proper joint compound should be used to ensure good electrical contact and prevent oxidation at connections. Copper is more forgiving during installation, but proper torquing of connections is still essential to prevent overheating and ensure reliable performance. Maintenance requirements for aluminum and copper busbar systems are generally similar. Regular inspections should be performed to check for loose connections, corrosion, and other signs of damage. Connections should be retorqued periodically to maintain proper contact pressure. Cleaning the busbars with a suitable cleaner can help to remove dirt and debris that could contribute to corrosion or overheating. The environmental impact of aluminum and copper production is another factor to consider. Aluminum production is energy intensive, but aluminum is also highly recyclable. Copper production can result in pollution and habitat destruction, but copper is also a valuable and recyclable material. When making a decision about which material to use, it's important to consider the entire life cycle of the busbar system from production to disposal. In summary, aluminum busbar trunking systems offer advantages in terms of cost, weight, and corrosion resistance, while copper systems excel in conductivity, flexibility, and heat dissipation. The best choice depends on the specific requirements of the application, as well as environmental and economic considerations. Always consult with qualified electrical engineers and contractors to ensure that the selected busbar system meets all applicable codes and standards and provides safe and reliable performance. Consider the ambient temperature where the busbar will be installed. Higher ambient temperatures can reduce the current carrying capacity of both aluminum and copper busbars. The earthing factors, as specified in the NEC, should be applied to account for these temperature effects. Also evaluate the short-circuit current rating of the busbar system. The busbar must be able to withstand the high currents that can occur during a short-circuit fault. The short-circuit current rating is determined by the size and material of the busbar, as well as the bracing and support system. Consider the type of insulation used on the busbar. Different insulation materials have different temperature ratings and dielectric strengths. Choose an insulation material that is appropriate for the operating voltage and temperature of the system. Evaluate the grounding system. A proper grounding system is essential for safety and to prevent electrical shock. The grounding system should be designed to provide a low impedance path for fault currents to return to the source. Consider the harmonics content of the electrical system. Harmonics can increase the heating of busbars and other electrical equipment. If the system has a high harmonics content, it might be necessary to use a larger busbar or to install harmonic filters. Evaluate the mechanical stresses on the busbar system. Busbars can be subjected to mechanical stresses from vibration, wind, and seismic activity. The busbar system should be designed to withstand these stresses and to prevent damage. Consider the ease of installation and maintenance. Busbars should be easy to install and maintain. The design should allow for easy access to connections and other components. Also evaluate the availability of spare parts. It's important to choose a busbar system from a reputable manufacturer that can provide spare parts and support. Consider the cost of the busbar system. The cost of the busbar system should be weighed against its performance and reliability. It's important to choose a system that provides the best value for the money. In addition to the above considerations, it's also important to consult with local codes and regulations. Local codes and regulations might have specific requirements for busbar systems. Ensure that the selected busbar system complies with all applicable codes and regulations. Furthermore, consider the future expansion of the electrical system. Choose a busbar system that can be easily expanded to accommodate future load growth. This can save money and time in the long run. When designing a busbar system, it's important to consider all of these factors. By carefully evaluating the requirements of the application and choosing the right materials and components, one can ensure that the busbar system provides safe, reliable, and efficient performance. Remember to consult with qualified electrical engineers and contractors to ensure that the selected busbar system meets all applicable codes and standards. A well-designed and installed busbar system is critical for the safe and reliable operation of an electrical power distribution system.